SimuleD, hardware-in-the-loop simulation of electric motors. Electric drives play an important role for new developments in the aerospace and automotive industries. The first electric cars are already available in the marketplace, and in the aerospace sector, electric drives are starting to replace existing hydraulic systems. The main components of an electric drive are the electric motor and the corresponding inverter controller. Both of them are decisive for the performance of the drive and, furthermore, for the drivability of an automobile. The interaction of both components is validated using a machine bed. It allows a very realistic simulation of the drivetrain, but has various drawbacks. The setup and operation of such a machine bed is costly. Due to the rotating parts in this setup, extensive safety precautions are required. Finally, the electric motor used needs to be available, which is not always the case during the early development phases. If the focus is on testing the inverter controller, an e-motor simulator can be used instead, thereby avoiding the disadvantages mentioned. The e-motor simulator SimuleD from Silva Athena simulates the counter EMF voltages of a real e-motor, so that the actual currents will flow and the inverter controller sees a real load. The simulator can operate as a motor or generator with power of up to 150 kilowatts. Furthermore, SimuleD allows emulation of all other interfaces of a real e-motor, like different position and temperature sensors. Because the behavior of the counter EMF voltage is calculated by a model, SimuleD can reproduce synchronous as well as asynchronous motors. All motor parameters can be changed on the fly, thus enabling easy fault simulation. The counter EMF voltage is controlled with a frequency of 100 kHz, because only then electrical rotor frequencies of up to 2.5 kHz can be exactly reproduced. Another advantage of the e-motor simulator SimuleD is the integration of the battery simulation, which enables the circulation of the energy. During motor operation, the energy flows from the battery simulation through the inverter controller back to the motor phase simulation. It feeds the energy into an intermediate supply network, which in turn supplies the battery simulation. During generator operation, the energy flows in the opposite direction. Because all components only have a limited efficiency, the energy lost during one circulation is replaced by power supplies connected to the intermediate supply network. The advantages of the energy circulation compared with other solutions are, firstly, the lower energy consumption of the simulator, and secondly, that there is no need to feed back energy into the supply network. Besides the energy circulation, SimuleD also convinces due to the implemented user safety features. The inverter is mounted within a security enclosure, the door of which can only be opened after all connections have been discharged. All interfaces between inverter and the environment are galvanically isolated, such that during operation or a malfunction of the inverter, no user can be harmed. The simulator is very compact and very quiet due to the non-existent mechanical parts, so it can be utilized in office and lab environments. This in turn allows the simulator to be used in system test, component test, and at the end-of-line test. The adoption of the e-motor simulator SimuleD from Silva Athena offers the user many advantages. It enables a decisive reduction in development time, and thus in time to market. The possibility to vary all the motor parameters and the simple fault simulation ensure a higher quality and improved safety of the developed inverter controllers. The flexibility and scalability of the simulator make it ideal for future applications. SimuleD, hardware-in-the-loop simulation of electric motors. Silva Atena. We develop today the technology which is called progress tomorrow.